Arkadaşlar günaydın. İsterseniz yavaş yavaş başlayalım. Okay, we were talking about the white box testing. We repeatedly emphasized that white box testing is a structural testing, which means the source code is required to perform white box testing, and we talked about the graph structures, flow graph structures, data flow structures, and we showed how a control graph is prepared from the statements, and then we mentioned how we will define different coverages on a control flow graph, and then we for each different coverage concept, what a complete coverage criterion is, and we also associated different coverage concepts, the statement coverage concept and branch coverage concept, and we associated them with each other. And we also showed how white box testing may be critical when used with black box testing approach. How a black box testing approach, that means a testing that didn't require source code, can be sometimes missing some very important errors that may be located easily using the source code in a software product. And we were continuing, we were going on discussing with the different coverage criteria. Well, let's, if you remember, we last discussed this flow graph, and we said that this whole graph is provides complete statement coverage criterion, because with these two test cases, -1 and 1, all 14 nodes, all 14 statements can be stimulated, can be activated, can be sensitized, if we may. But only 94% branch, the same test cases cover or provide only 94% branch coverage. And that's because this node, I'm sorry, this edge is not covered. This edge is not covered, but since there is no node here, we reach a complete statement coverage criterion, but we only get 94% branch coverage. And out of this discussion, we concluded that statement coverage is not equal to branch coverage. And branch coverage, we also concluded that branch coverage is a stronger criterion. Branch coverage subsumed or subsumes that is includes the statement coverage. So now after this discussion, now let's continue to define still different versions of coverage criteria or different coverage concepts. Condition coverage concept is another version of coverage concept. Let's see what it. Okay, before this, before going into the coverage condition coverage criterion, let me ask you people: do you actually understand what's going on in the statement coverage and branch coverage? And do you further understand that branch coverage is a stronger coverage criterion? I would like you, okay, if you don't, again, I would like an answer from each of you. And if you don't understand, please let me know so that I can explain. A simple yes would be fine if you do understand. If you don't, please let me know. Please write from your chat panel so I can further clarify what's going on. Otherwise, I will go to another coverage criterion, which is the condition coverage. Well, I get only an answer from 4 people, and none of them said I don't understand. So I will pass to the condition coverage criterion. Well, condition coverage criterion is another coverage concept, and it is actually stronger than both statement coverage and branch coverage. Well, let's see what it means. A set P of execution paths satisfies the condition coverage criterion if and only if for every control node in the flow graph consisting of atomic predicates C1 through Cn, each Ci yields true, that is yes, when evaluated within a path P1 in P, and Ci yields false, that is no, when evaluated within a path P2 in P, where I is between 1 and n inclusively. So that means for each condition in a decision structure, I will have a different test case, not a different test case, but a test case that will sensitize the path for this Ci where it is equal to yes or true, and I will have another test case that will sensitize the same predicate, the same condition for its value false. So I will have at least two test cases, each sensitizing, each activating a path, an execution path for each value of a control predicate or a condition in the decision structure, where the decision structure is composed of C1, composed of conditions from C1 through Cn. All right. So do you understand that? Do you have any questions? For example, let me give you an example, and then I would expect an answer. Well, for example, this one, this condition here, this condition here, okay? This here is composed of C1, C1, and C2, okay? C2. And these conditions, these two conditions, uh, are related to each other with an OR gate, okay? So C1 is this one here, and C2 is this one here, okay? So what this coverage criterion does, we have to use two test cases for CI, okay, CI and C1, that will two test cases for C1, for this one, where where each will sensitize true or false for this one. Okay, so two possible test cases, for C1, for example, is let's say, I'm sorry, I is equal to 1, I'm sorry, I is equal to -1, and I is equal to 1. Okay, so this will sensitize C1. Now for C2, I is equal to 101, for example, a boundary case, and I is equal to anything less than 100, less than or equal to 100. Well, how about 1? C2, for C2. So now, as you see, for this one, we have covered the values true and false. With this one, we have covered the true answer for C1, and with this one, we have covered, with this test case, we have covered with this one, we have covered a true case, and we have covered with this test case, a value false of C1. And for the same way, with this one, we have covered the true value of C2, and with this one, we have covered the false value of C2. Okay, but as you see, I'm sorry, as you see, we have used 3 test cases in total to cover both conditions, true and false values. we have used 3 test cases. How did that happen? Because I equal 1 worked both the false value of the C1 and for the true value, I'm sorry, for the false value of C1 and for the false value of C2. So the false value of for each of these conditions, the false value could be covered by 1 test case. So that's why in total we needed 3 test cases to test this condition. So the condition coverage criterion, is can be defined using this statement, and we have shown it using this example. Do you understand what's going on? Do you have any questions here? Okay. All right. So we call each of these condition in a decision structure. Each of these conditions a predicate. Okay, each of these conditions are called a predicate of the decision structure. So keep that in mind too. Well, let's now come to the multi-condition coverage criterion. Let's define multi-condition coverage criterion. A set P of execution paths satisfies the multi-condition coverage criterion if and only if for every control node in the flow graph consisting of atomic predicates C1 through Cn. Now, pay attention to this part. Each possible combination of their truth values, true, yes, or false, no, is evaluated within at least one path P. Okay? So each each possible combination of their truth values. So you understand the difference at the condition coverage criterion. At the condition coverage criterion, we tested each one. We tested each one only for their true and false values, and we didn't care whether or not this could be done with the. I mean, this could be their different values could be tested using the same test case. All right. So in this time, at this time, with this multi-coverage condition criterion, now we have to check. We have to make sure that each possible combination of their truth values is evaluated within at least one path, in one execution path. So that means now for this again for let's go back to this example. Okay, what we need to do is, last time we checked out the true and false for both. All right. Now this time we have to check, we have to create test cases or use test cases for four different combinations. for C1 and C2, they need both be true. Okay. They need to be true, false. They need to be false, true. And they need to be, let me write it here, false and false. So these make in total, four different test cases. Okay. We can, of course, for these two specific conditions, predicates, it's not possible to find a test case for this one. Okay. Well, for this specific test case, we cannot find a test case where both are true, of course. Well, that's okay, but this is because of the specific conditions themselves. It doesn't have anything to do with the white box testing or its principles. But yeah, in general, not specifically for this test case, but in general, what multi-condition criterion, coverage criterion, tells us is we have to find a test case for each of these four conditions, for each possible combinations of the values, right? Do you understand this? Do you understand the difference between the condition coverage criterion and multi-condition coverage criterion? Okay, now each of you guys, I expect an answer from each of you people. Which one is a stronger coverage criterion among uh, condition coverage criterion and multi-condition coverage criterion? Which one is stronger? I'm expecting an answer right now from each of you. Which one is a stronger coverage criterion? Okay, perfect. Well, all those who answered gave a correct answer. That's right. Multi-condition coverage criterion is a stronger criterion. Okay, now I expect an answer I expect an answer from uh, considering all coverage criteria: statement, branch, condition, and multi-condition. Which one is the strongest coverage criteria? Okay, I am still waiting for your answers. Well, perfect. Yes, multi-condition coverage criterion is the strongest coverage criterion so far among statement, branch, and condition and multi-condition coverage criteria. Multi-condition coverage criterion is the strongest criterion, and you all uh, answered that correctly too. Thank you. Well, I will continue then. I see that you understand the concept, so I will continue now. Now, path coverage criterion is the strongest coverage criterion among all. Uh, Now, I would like to ask you people a question, and this, if you can see what is going on here, then you perfectly that means you perfectly understand the whole thing. Well, what is the difference between the multi-condition coverage criterion and path coverage criterion? Path coverage criterion being the strongest criterion among all. What difference may it have between itself and the multi-condition coverage criterion? Can you now think of it? Think of it, and uh, uh, well, try to give an answer. What is the difference between the path coverage criterion and multi-condition coverage criterion? Okay, now I will show you this. I will show you this. Yep, this one here. Now, thinking of this, how would you answer? How would you answer the difference? How would you show the difference between the multi-condition coverage criterion and the path coverage criterion? Okay, well, let me. I have a better idea. Let me draw here. Let me draw here an example control flow graph. Okay, we have two conditions here. We have two conditions here. Let's say C1 or C2, and true, false. And we have another condition here. And here we have C3, let's say, and C4. I'm sorry about the script, please. But you see, right? You see what's going on. Again, we have, for example, true here, and we have a false here. Okay? So now here, can you show me, what, can you tell me how the multi-condition coverage criterion and path coverage criterion differ? So at this one, we have Okay, let me. We have here C1, C2 at first decision structure, and C3, C4 at the second decision structure. All right. So now, can you, well, what is path coverage? Let's talk about this and then see, try to understand the difference. Okay, when path coverage means, um, okay, let me here, let me see. Okay. Let me try to finish this. Okay, this is a statement S1. Okay, now how can I test in my multi-condition coverage criterion? In my multi-condition coverage criterion, what possible values should I test? For C1 and C2, right? What I need to do is to, okay, to find two test cases for C1, true and false that are, okay, or let me, okay, well, let me write here. No, this is not. Well, first let me write here two test cases for C1, two test cases for C2, again, true, false. Two test cases for C3 and two test cases for C4, right? What is, okay, what coverage criterion is this? First, let me hear the answers from you for this. What criterion, what coverage criterion is this one? Now, this one, since it is checking, since it is using, okay, one test case for each predicate, what may it be? Okay, perfect. Kevser and Ertuğrul gave correct answers. This is condition coverage criterion. All right. Now let's write here, let's write the multi-condition coverage criterion. How may this one look like? Or let me hear your answers to this question. How many how many uh, test cases how many test cases should exist to perform a multi-condition coverage criterion for this example control flow graph? How many test cases? Okay, what did we do for the multi-condition coverage criterion? We have, okay, we have C1, C2, C3, and C4. We have four predicates, right? Four predicates. For multi-condition coverage criterion, what do we need to have? For C1 and C2, all right? Since they're at the same decision structure, we should have four for this one, right? A truth table for C1 and C2 would give us four different combinations, all right? And at the second decision structure, we have another set of two predicates, okay? For this one, four test cases at most, may be better, but four test cases, because we have four different combinations of truth values, right? Which is equal to 2 to the power of 2. And for this, another four test cases. So add them up together. That will in total give us 8 test cases. Okay? So this here is multi-condition coverage criteria. Do you understand now? Do you understand this one? Okay. Now let's check the path condition coverage criteria. How will we calculate the path coverage criteria? Now we have four different cases. C1, oops, sorry. We have C1, C2, C3, and C4. Okay? So for each of these, we may have a different path case in the worst case. Okay? So That means but this is in the worst case. Not looking at this, uh, control flow graph. Okay, in the worst case, we may have four. We have four predicates that may lead to 16 2 to the power of 4 2 to the power of 4 different paths, which is equal to 16 paths. All right. So in this case, in the worst case, again, in the worst case, we may have to use 16 different test cases. Okay, but this here, okay, this whole thing here, this whole thing here is not the worst case. It is not the worst case. Why? Here we have, okay, for each possible truth value combination, what we get is 1, 2. Okay, let me draw each of these using another color. Okay, we have 1, 2, 3, and 4 different paths, different execution paths. Out of the possible truth combinations, out of all possible truth combinations of these 4 predicates, what we may get for this specific example is only 4 different paths. 4 different paths, all right? But this, in another control flow graph, in another piece of code, with a different combination of predicates in different structures, different decision structures, we may have at worst, at most, 16 different test cases. I'm sorry, 16 different paths, and this will end up with, at the worst case, with 16 different test cases. Do you understand that? Do you have any questions, or maybe I didn't explain it well? Please let me know so that I can try to answer your questions. Okay, perfect. All right. Okay. So you understand the differences between the condition, multi-condition, and path coverage criteria. And from this example, you understand that we have so different test cases for condition and multi-condition and path criteria. And you also understand that path coverage criterion is the strongest criterion. Okay, perfect, perfect. All right, I will also try to solve an example today, but let us now continue. Otherwise, Berna will definitely solve an example in the problem session. Well, now let's come to, okay, this is oops, sorry. This was the path coverage criterion, and now let's talk about the independent path coverage criterion. Let's first talk about the concept of independent path, and then let's see how we perform, how we reach independent path coverage criterion. Well, first of all, independent path, not path coverage criterion, but independent path coverage criterion is stronger than branch coverage. It is also used in complexity analysis of programs. So, well, let's first, okay, well, we have talked about let's come here again, and let's let me remind you of the independent path, what an independent path is. An independent path is this. Well, this here is an independent path. This here is an independent path. And this here is another independent path. And here, the independent paths are actually, the number of the independent paths is actually equal to the number of all paths, all right? Here, now let's see, here we have a loop. Let's see what independent paths we have here. Let's first see what paths we have here. This is a path, okay? This is a path. Well, this is a path. Are there any other paths? Not independent paths. Are there any other paths? Yes. We have this path, for example. Oh, let me draw this using another color so you can see it better. Well, we have here this path. This is another path. Since we have a loop there, this is another path. Okay? And, well, this here is another path. But the last two are not independent paths. The last two are not independent paths. All right? So we have three independent paths. Three independent paths. We had this discussion with one of you people who said that this one, I'm sorry. Okay. Now, this one and this one. Are they independent or not? Well, actually, this one can be written using this one. Okay, but in our calculations, in our defining independent paths, we consider these two different independent paths. Okay, please make sure that you do the same. Okay, the concept of independent path is not like the concept of linear independence. Okay, please make sure that you consider this and this two unique independent paths. Okay, do you understand that? So these two are two independent paths, not like the concept linear independence. The independent path concept is a little different, all right? So these two are two independent paths. Again, make sure that you consider the zero time execution loop and one time execution loop as two independent paths. Please make sure that you know this. Okay? Now, given this concept of independent paths, let me go back to cyclomatic complexity. Now, what is cyclomatic complexity? Oh, I'm sorry. Okay. Let's take a break and be here at 9:33 after 10 minutes. All right. Let's take a break. Let's take a 10-minute break. Okay. Well, let's talk about the cyclomatic complexity. Uh, Cyclomatic complexity of a piece of code is the number of its linearly independent paths through the piece of code. For example, for a piece of code with no decision structures, the cyclomatic complexity is equal to 1, meaning there is a single linearly independent path. Okay. So that means cyclomatic complexity of a piece of code is the number of its linearly independent paths. Given, well, what is the formula for the cyclomatic complexity? Given that the source code is represented as a directed graph, that is to say a control flow graph, then the cyclomatic complexity can be formulated as the number of edges in that piece of code or in that control flow graph minus the number of nodes plus 2. Okay, E is the number of edges and N is the number of nodes here. So again, the cyclomatic complexity is equal to the number of edges minus the number of nodes plus 2. Well, let's give an example here. Let's count the number of nodes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So these are the indices of the nodes. So we have 13 nodes. How many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Of course, since there are no nodes here, we count this as a single edge. So we have 14 edges. 14 minus 13, 1, plus 2, 3. So we must have 3 linearly independent paths here. Again, this is the first one, this is the second one, and this here is the third one. But let's look at this one. Let's look at this one. Let's count the number of uh, nodes and edges and see what really is the number of what is the cyclomatic complexity in this one. So again, the number of nodes, the number of nodes, uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So we have 15 edges in total, including the begin and end nodes. 15 nodes, right? How many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So we have 16 edges. Okay. So our cyclomatic complexity is then is equal to 3. So, and these independent paths are, again, one more time, let's draw them. This one, this one, and this one here. Okay. Do you understand that? Do you understand how we can find the cyclomatic complexity out of the number of edges and number of nodes in a given flow graph, controlled flow graph? Okay, great. So then let's continue. Okay, let's look here at each specific independent path. So we express the independent paths using the number of nodes. As you have learned in data structures, a path is defined by the nodes, by the sequence of nodes on the path. All right. So the independent paths here are the first one is 1, 2, 3, 8, 9, 10, 11, 7, and 15. Another one is 1, 2, 3, 4, 5, 6, 7, and 15. And the last one is 1, 2, 3, 8, 9, 10, 11, 12, 13, 14, 8, 9, 10, 11, 7, 15. So we have three independent paths, three linearly independent paths. And as I said before, we consider the path of the execution of the loop for a 0 time and for a 1 time as two separate, two unique independent paths. All right. So this is the 0 time execution. This is the path of the 0 time execution of the loop in that source code, in that control flow graph. And this here is a 1 time execution of the loop. Okay. Well, let's look at this. Let's look at this um, uh, flow graph, and let's see. This is another example for coverage comparison. Well, this here is the code line for which we draw here a control flow. If x is not equal to 0 and z is greater than or equal to 0, which is this decision structure, then y is equal to z over x. So if this is true, then this statement is executed. So if this is true, yes, then this statement is executed. If no, then the execution goes without executing this statement to that point. Okay. Now, uh, well, let's look at this example and tell me. Well, I will again expect an answer from each of you people for a complete statement coverage criterion. For a complete statement coverage criterion, what would be a minimum number of test cases for this control flow graph? Minimum number of test cases for the complete statement coverage criterion. I expect an answer from each of you people for a minimum number of test cases of a complete statement coverage criterion. Of course, the test case will be okay. uh, Well, please give me the test case. Yes, give me the values of x and z. Give me the values for each test case. Give me the values of x and z, please. I'm asking you again. I am asking you for the minimum number of test cases, and I want you to show me what the test case is for the complete statement coverage criterion. Complete statement coverage criterion. Okay. Well, test engineering is a complicated thing. I accept this. Uh, uh, let me okay. Uh, Let me first start then. All right. I'm not asking. Okay, because there are two uh, there are two different. There are many different answers. Okay, and well, some of them are right, but mostly I think it's not clear. Uh, well, let me first start by getting answers to my to an easier question. How many? What is the minimum number of test cases? Let me go back to that. What is the minimum number of test cases for a complete statement coverage criterion for this control flow graph? Let me first start by this question. All right. What is the minimum number of test cases? What is the minimum number of test cases for this for a complete statement coverage criterion for this control flow graph? Let me get this. Let me get answers for that question first. The minimum number of test cases that will provide a complete statement coverage criterion for this control flow graph. Don't forget, it is the complete statement coverage criterion. I have answers from Kevser, Anıl, and Nur Deniz Çaylı. What are okay? And Fırat Çetiner. Elif, Fırat, Kevser, Anıl, and Nur. I have answers from these friends. What do the others claim? What are their suggestions? I have only 5 answers. What do the others say? Okay, I have well, no problem. If you don't, if you okay, no, if you don't understand, that's fine. But then you should ask questions. Well, all right. Let me. Okay. I think I have 10 answers. Well. Uh, okay. What was the complete statement coverage criterion? Let's go back to that first. Let's just check it out. A set P of execution path satisfies the statement coverage criterion if and only if for all nodes in the flow graph there is at least one path P in P such that P contains the node M. And the complete statement coverage criterion should provide a path for each node. Okay, a path for each node. an execution path for each node. Now let's come back to that example of ours. So we have, if we go through this path, if we can sensitize this path, all right, if we can sensitize this path, then we can we can test both of these statements, both of these nodes, right? So for only one test case that will sensitize this path is enough. So minimum number of test case, okay, is equal to 1. Do you understand that? Since we have two nodes, but since one execution path, if we since we can sensitize both nodes, if we sensitize this path, then one test case will be enough if we can sensitize with this test case both nodes. Do you understand that? Okay. So now, what test case will sensitize this execution path? Well, for this execution path to be sensitized, this decision structure must go to the true value. So for this multiple condition to be true, x must be equal to something other than 0, which may be 1, for example. Okay. And z must be greater than or equal to 0. Z must be equal to 0, for example. Okay. So this, or anything which makes both conditions, both predicates true, is fine with us. Okay. This is an example test case, and the minimum number of test cases is 1. Now, do you understand that? Do you have any questions on that? Okay, perfect. If you have any questions, please let me know from the chat panel. Now, I will ask the next question. What is the minimum number of test cases? What is the minimum number of test cases that will provide a complete branch coverage criterion? Now, what is the minimum number of test cases that will provide a complete branch coverage criterion? I will wait another minute. I have 6 answers. Most of them are right. 5 of them are right. Okay. Well, we said branch coverage criterion. What was the branch coverage criterion? Let's go back. Okay. Let's see what the branch coverage criterion was. A set P of execution paths satisfies the branch coverage criterion if and only if for all edges in the flow graph there is at least one path P such that P contains the edge E. So each control flow branch decision, true yes or false no, is taken at least once during testing by some test case. So now let's go back. Let's go back to our example. Okay. So we have uh, okay, we have two paths. Okay, we have two paths to go to cover each edge in the control flow graph. Okay, I have these edges covered by this path, and I have this edge covered by this path. Okay, so that means I have to sensitize two different paths to cover to provide a complete branch coverage criterion. All right, so that means I can use this first one. Okay, I can use this first one. Sorry. Okay, let me. Oops, sorry. This one here. This one here is the first test case, and which sensitizes this path above, and I need another test case that will sensitize this path, and this path can only be sensitized if this decision structure is false. All right, for example, x equals 0 and any value of z, for example 0 again, these two test cases will sensitize the two paths I have shown you here, and this will this will provide a complete branch coverage criterion. Do you understand that? So I need for the statement coverage, a complete statement coverage, I need a single test case, and two test cases are enough for a complete branch coverage criterion. Okay, do you have any questions on that one for statement coverage criterion and branch coverage criterion? Do you have any questions? This is important. Anything that you don't understand? Okay, okay then. Well, let's talk about the uh, uh, uh, condition coverage criterion. How many test cases? What are the test cases that will give me a condition coverage criterion? Or uh, let's look at the next page and see what is going on. All right. But for the complete statement coverage, one test is enough. For the complete branch coverage, two tests are enough. For complete condition coverage, where okay, let's go back. For the complete condition coverage, what test cases would I need? Well, for condition coverage criterion, what is the definition? I have to cover each predicate. All right. Well, let's look here. A set P of execution path satisfies the condition coverage criterion if and only if for every control node in the flow graph, consisting of atomic predicates C1 through Cn, Ci yields true when evaluated within a path P1 in P, and Ci yields false when evaluated within a path P2 in P. All right? So, so come back to our example. Now, what is the condition coverage criterion? What test cases do I need for a complete condition coverage criterion? So I have this control node. I have two predicates in the control node. All right. For each of these, I need to sensitize the true value and false value for each predicate. So let me write them down then. For each predicate, and here, please pay attention to that. If I can find a test case that will sensitize, that will provide a test for uh, any value of any condition, then I will of course use this, because that will optimize the number of my test cases. All right. So, for example, x equal to 0 and z equal to 0 will make true for C1, true for C2 and true for C2 and false for C1, right? Another test case, x equal 1 and z equal -1. Now this one is true for C1 and false for C2. Okay, I have two test cases. Do I need any more? Do I need any more test cases for a complete condition coverage criterion? Oops. Do I need any more test cases? I wouldn't need any more. Why? Because each test case, each predicates, each value of each predicate has been tested using these two test cases, right? Uh, uh, C1 is tested for its false and true values, and C2 is tested for its true and false and true values uh, using these two test cases. So I wouldn't need any more test cases. What would be, okay, another question is, what would be an alternative set of test cases for the complete condition coverage criteria? Okay, x is equal to 0 and z is equal to -1, x is equal to 1, and z is equal to 0. Okay, this is another set of two test cases that will also provide for the complete condition coverage criterion. Okay. Well, now I have questions. That is great. So this is another alternative set of two test cases for the complete condition coverage criterion. Now I have a question. Let me answer that. Uh, well, I have for the statement coverage. The question is for the statement coverage, for a complete statement coverage criterion, don't we need two test cases? This is the question. Well, no, we don't need two test cases because uh, because uh, uh, both nodes both nodes are on this both nodes are on this execution path, all right? And I can, using a test case, I can sensitize the execution path, and I can this way test both statements at using one test case only, all right? Let me repeat the test case. X equal to 0, oops, I'm sorry, x equal 1, let's say, and z equal to 0, right? That was what we wrote. Nur, well, using this test case, I have a yes from this decision structure because both of these predicates are true. So I go through here, and now With these values, I also test this test case, this statement, okay? And this way, using a single test case, I have tested both this statement and this statement. Do you understand that? Nur, do you understand that? Okay, great. So that's why we only need one test case. You're welcome. Okay, now let's one last question. One last question. What is the number of test cases for a complete multi-condition coverage criterion? For a complete multi-condition coverage criterion. Okay, the question is, what is the number of test cases for a multi-coverage condition criterion, complete multi-coverage condition, complete multi-condition coverage criterion? And Ertuğrul has a question: in complete condition coverage, while we provide true for predicate one, do we need to provide false for? No, I gave you two alternative sets of test cases. You can also cover true true and false false. That's also possible. Or you can cover true false and false true. So using two test cases in both ways, you cover you provide a complete condition coverage criteria. Ertuğrul, do you understand? Okay, you're welcome. Now, back to my question. What is a the minimum number of test cases for a complete multi-condition coverage criteria? Well, here I have well, let's write the answer down. X equals 0, and Z equal 0 for true, true. Sorry, I'm sorry. Let me write it like this. For false, false, X equal 0, Z equals 0 for false, true, X equal 1, Z equal -1 for true, false, and X equal 1, Z equal 1 or 0 for true, true. Okay? So this is for a complete oops, complete multi-condition coverage criterion. Let's check these out in the next slide. Well, we have said one test is enough for complete statement coverage. Two tests are enough for the complete branch coverage. Complete condition coverage, two tests again, as we wrote down. And for the complete multi-condition coverage criterion, we need 4 tests. We need 4 tests. So, well, do you have any questions on the comparisons of coverages? Do you have any questions on the comparisons of coverages? Okay. Well, okay. Let's talk about the very briefly about the selection of test cases. A certain code coverage criterion and percentage, 100% branch coverage, has been chosen. One has to design test cases to reach the criterion. Okay, so we have to use, as I said before, we have to use as a small number of test cases as possible. We have to be able to optimize the number of our test cases. All right. Construct a flow graph for the program with a white box tool, and then choose the execution paths that satisfy the criterion. For each execution path, design a test case, that is program input output, that activates a traversal of the path. Execute the tests with a white box tool again that calculates the coverage. If the required coverage has not been reached, return to step 3 to design additional test cases for those execution paths that have not been traversed yet during testing. So, well, path sensitization, what is it? The process of designing a test case for a particular execution path. In general, path sensitization is undecidable. There is no algorithm that can find a suitable test case for each possible path. Symbolic execution and equation solving tools succeed in some cases. So a heuristic can be used. We can begin with the control conditions of a branch at the end of the path and select such variable values that will satisfy these conditions. Repeat this analysis for each prior branch in the path until you reach the entry node of the flow graph. Use the selected values of the input variables as the test case for the path. Well, there may be some infeasible paths that cannot be executed with any input, caused by short circuit evaluation, contradictory or mutually exclusive control conditions, and redundant control predicates or dead code. Okay, and well, the crucial points in a flow graph are those where the execution diverges. Divergence points of execution is those points. Okay, this, for example, this point is where the execution diverges. That means the execution is separated into several paths. Okay, the execution diverges in this point. That means the execution goes into different paths. The execution is distributed into several different paths. That's what divergence of execution means. Okay, so these are where execution diverges is the crucial points in the flow graph. All right, so one has to find the input values such that when executing the program with the input, control branches into the desired direction and the predicate P obtains the corresponding value or value combination. Okay, well, let's look at these final several slides in the coming week, and then we will solve an example, and then we will finish white box testing and go to the software cost estimation. Well, I will see you next week. Till then, goodbye. Have a nice week.